In the last episode, we talked about structs in Rust. If you want, you can check the previous video. I will leave a link below. And in this video, we will do something very simple. We will try to make some examples. So this is a practical example of how you can use structs in Rust. Structs is a compound data type in Rust. What does it mean? It's a type that you can use to have multiple data types in the same structure. We'll see also why we should do this. So let's start with a very simple example, and we can start by not using structs. So we will make 2-3 examples, and at the end you'll understand why structs can be useful. They have a key value pairs. So basically we have named values. Let's start without the structs, and let's say that we want to create and calculate the area of a rectangle. So something super simple. This is similar to this is basically what we have on the book, but we want to explain and go a bit more into the details. So what do we need in order to calculate the area of a rectangle? We can have a width, for example, 30, a height, 50, and then we can print this area. Okay. To do this, we should create a function. So let's create the function first. We can have a function called area calculation like this, and we can simply return the width and the height multiplied, and that's basically the area. I hope you know the signature of a function in Rust. Otherwise, there is a lesson called functions if you want to understand. But simply we have these two arguments, then we have an arrow, and then we have the return type. So this is it should be clear. So we have print ln, the area of the rectangle is like this. So let's do a simple cargo run -q, and we have what we expect. So nothing strange here. We have the area of the rectangle is 1500. What's the problem here? If you are in the chat, you can try you can try to say what's the problem here. Of course, we are using trivial examples, almost trivial examples, but try to think like this in like a more complicated program, a more complicated function. Let's try to predict how code without this might get more complicated. For example, if we have multiple variables, multiple areas to calculate. If you want different calculations, yes, of course. I think that here the bigger problem is that we are defining, we're defining these two variables here on line 2 and 3. And then we have this function that uses these two variables. But think about, we don't have the logic is just because we have them on line 2 and 3. But I don't know, if I put these here, probably I'll have a problem. Let's see. We have an error, for example, here. Let me show you what is another issue here. Let me show you here. Let's say that I do a very dumb mistake, which is very likely to happen. So let's say that I do this. I invert height and width just because I don't know. I'm going quick. That's okay. Let's try to do the cargo run. So it seems that we don't have a bug, but think about having, I don't know, that maybe we want maybe these two dimensions they matters. Maybe we want to print this rectangle on the screen, or we want to create a model. And then we'll have a model instead of like this. We'll have a model which is like this. So you see, and here it's not that easy to spot the bug here, because even like this in 10 lines of code, is a width height is here and width is here. You see, this bug can be very annoying. Do you agree? Let's see. Think about having like a way more complicated thing. So this can lead to many problems, I would say. Okay, so let's try to solve this issue, and let's try to use tuples. Before we will use tuples first, and then we will do this with structs, so with tuples. Let's try. A tuple is a data type that has multiple types inside it, but they have no names. Everything is used based on the order we provide them. So like this, we can have let a rectangle, rect1, like this. We understand that a rectangle has 2 dimensions like this, and then we can have a function here. You can call this function area again with these dimensions, so a single parameter, which are the 2 dimensions, dimension.0 multiplied dimensions dot 1, and then we can print this. So this is one, let's say, update. So let's try to do here calcul_q. We have the same output, so nothing's changed here. Is this better or not? I don't know, to be honest. Did we solve the issue? Because now we don't even have the let with let height. We have this rect1, we have this rect1 equal, and then we, I don't know, maybe usually we do first the width and then the height, but I think at the code, maybe you'll share this with someone else. So it might be even worse, I'll say. But there is, I have to say that there is an improvement here. The improvement here is that these 2 dimensions, in this case, they are tied together. We will use, in this case, the first dimension and the second dimension together in the signature of this function. So I don't know if for you this is a better version than the previous one, but I think an improvement is here. On line 11, we have, instead of 2 random values, so we have instead of 2 separate parameters, we have a single one, which are the dimensions that we need to calculate the area. Okay. Okay, I forgot to record the video, but it's okay. I'll use the recorded version on YouTube. I should hit the record button at the very beginning. It's okay. It's okay. I should record every time I go live, but I don't want that option. But it's okay. I can still use it, the normal one on YouTube. I did the 2 during my last one. Perfect, Adarva. Yes. It's okay. Probably will have a good version and not. I'm that close, tempted to just do it again, but it's okay. Okay, so I think this is a sort of improvement, but now let's try to do this with structs. So we'll see a practical example with structs. So with structs, to be honest, a single struct. So we can have a struct. Let's see if there is an improvement or not. Called rectangle. Let's see if GitHub Copilot is smart. Width and height, and then we can have a function. Let's have this. We can have this. We can create an instance of this. Let's remove this for now. We can have an instance of the rectangle here. Let's create the function here. Let's create the function first. Function area, and then we have this rectangle colon ampersand rectangle. You should know what this is. If you don't know, type it in the chat and I'll explain again. And then we have a return type u32, which is rectangle.width multiplied rectangle.height. And I think that we need to print it here. Print the area of the rectangle is square pixels, and then the area, and then, and this is interesting, instead of passing two random numbers, we are passing what? We are passing a reference with the ampersand of the instance of the struct that we just created. Okay, let's see. Let's do cargo run -q, and we have the same output. But what's the advantage here? The advantage here is that I think it's this. As an area, we just give the instance of a rectangle. Now, this here we are just multiplying two numbers. But think about, I don't know, having an instance of a player, like in a game, or having the status of a part of the application or using a way more complicated object, and even worse, let's think about adding some functionalities. I don't know, now we are using a car, now we have a new number, now we have a new ID, we have something new, like is electric or not, so we can add something. A struct can also change in the future, and here we are just passing this instance of the rectangle, and here we are using, and this is very clear, this is what it's really great about structs, this that we have rectangle.width multiplied rectangle.height. So here we are using something very explicit. We are using these two values, width and height here. Okay, so this is a very interesting one. Okay, and this is basically, it's one simple example of how you can use structs. Before we wrap up this quick lesson, I want to show you a couple of things that I don't know if we made it on the last lesson, but let's do this again. How can we print this instance? Is there like a sort of like toString, for example, if you use Java? So let's remove this one, and then we can just have print the instance. How can we do this? If we do like this, you see this is a strange symbol like this. Let's try. We get an error. Let's read our compiler. Rectangle doesn't implement debug. Okay, let's read here. We need to add this debug trait here on top of this struct. Okay, like this. So let's try again. We have a couple of warnings. I'll tell you why. We have a couple of warnings because when we use the debug trait, the compiler also ignores everything that we do with this. So even if we print, you see here, rect1 is a rectangle, so we print it, the compiler ignores everything that is used in debug mode, so we get a warning. Okay, so we get this. This is interesting. We can also try something like this. I think it was something like this, print. We can also try like this, ln. This is basically just to format it. Rect1 is like this. This is syntax. Check line 13. On line 13 we have println rect1 is, and then we have this syntax. So colon, hashtag, and then question mark. I want to comment this. And let's try again. Ctrl L to clean the terminal, very useful for live streamers. Cargo run -q. I made a mistake. Okay, I forgot this exclamation mark. I don't have the Rust analyzer because sometimes the Rust analyzer makes some spoiler during my lessons. So someone asked me like, Francesco, why don't you use the Rust Analyzer, which is super useful to spot all these small mistakes, but I like to div dangerously. So usually I have that activated, otherwise you'll basically get all my questions when I make it. So this is of course makes my life a bit harder. Okay. No, you can do println too. Println exclamation mark is a macro. The problem here is that there was a space. Okay. And of course, if you want to print it in this case, you need to do like this. Okay, and check it out. Now it's printing this instance in this way. So rect1 is a rectangle, and I like how this is formatted now. This is just to show this. So if you like your instance to be printed like this, then you can have you can use this notation. Remember and be sure to add this derive debug. I really love the fact that in Rust we can, by default we don't have all of this, but we can add some traits with this notation, this hashtag, and then we can add, for example, clone traits. We can add something on top of something, and by default we don't have it. So we have this, I really like this default behavior, but then we can extend it in some ways. Okay, and I think that this, when we do when we compile the code for production, I think that this is automatically removed. Not sure, but it should be like this.